all it's telling me to do is I really need to find the second derivative of this function. What the heck is a second derivative? Isn't that just the derivative of the derivative? You know? So don't I just need to find the first derivative first? All right, so let's do that. We have this, I don't want to be using that color. We have this function x squared plus xy equals 5. I don't really feel like solving for y. So I'm just going to go ahead and use implicit differentiation because it's set up, like maybe that's just probably our best idea. So I'm going to take the derivative with respect to x. And the reason we're doing that is because keep in mind, we're trying to find dy dx right now. So I'm just going to take the derivative with respect to x so it kind of matches up with what I want. The first part's not too bad. Derivative of x squared with respect to x, 2x. And then I have to be careful, and a lot of times I'll put in little dots like that just so I can physically see that it's a product. And this is telling me, hey, use product rule. So I know I'm going to have the first function times the derivative of the second plus the derivative of the first times the second. And I was adding those two components together. What questions might you have so far? And then ultimately, I'm taking the derivative of both sides. Really, I'm saying like, hey, let's find the rate of change of both sides. If these two things are truly equal, then their rates of change should be equal. And so the rate of change of 5 is just 0. And so we're just finding the rate of change of everything. And then I can clean this up and I can write 2x plus, x dy dx plus y equals 0. Keep in mind our goal here was to find dy dx. So I'm just going to isolate dy dx, get everything onto the other side. So I'll have x dy dx equals, negative 2x minus y. And then I'm just going to go ahead and I'm going to divide both sides by x here. And ultimately, then we're going to have dy dx equals negative 2x minus y all over x. What questions do we have on anything we've done so far?
Can you simplify that now?
Yes. And I'm really glad that you asked that. Sometimes I won't be able to. So think about where we're at right now. Jenna is saying simplify. Sometimes I won't be able to, and sometimes I won't want to. Okay? So if I wasn't able to, let's just pretend that I wasn't able to, what would I have to do in order to get my second derivative? I would have to quotient rule, right? I would have to quotient rule. And so I'd have to be okay with doing that. And that's fine. I can do that. It's not a big deal. But Jen is absolutely right. This looks like it's simplifiable, if that's a word. And it's not just easy. It's not just simplifiable, but it's going to be nice, way nicer. Because I can really think about this as dy dx equals negative 2, right? Because it's really this fraction. And then I've also got this other fraction, negative y over x, which that one's still gross. I don't want it to look like a 4. That'd be a bad idea. Better, but gross, right? Questions so far? So let's get what we want, right? Like we want the second derivative, which is really just the derivative of the derivative. Right? You can even see why they write the notation the way they do, right? It kind of looks like they did d squared, they're just kind of using exponents to kind of write it in a simpler way, even though it's not really an exponent. And then the bottom, you can see why they wrote it that way too. So let's go ahead and do this. I'm going to go ahead and erase that, give us some workspace. And then we know that we're going to take the derivative of this thing with respect to x. Again, that gets us our second derivative. And so when we do that, on this left side here, the derivative of the derivative, well, it's just the second derivative. That's what I wanted. Great. Nearly done. Psych. Derivative of negative 2 with respect to x, that's just 0. Not a big deal. And then I'm still subtracting. And then I've got to be careful. Look at that next piece. What am I going to have to do? Quotient rule. And so let's go ahead and do that. I know the quotient rule, and does anybody want me to like label the pieces and kind of do it separately, or can we just do it all in one fell swoop? Like label them, Painter. Let's just do it, dude. All right, there it is. So I know it's low d high, so the denominator multiplied by the derivative of the upper function, the numerator, which is dy dx. And I'm going to put parentheses around this because I want to make sure I realize this whole thing is negative. Subtract high times the derivative of the upper, which is just 1, and I'll write that there just for us. And that's all going to be over x squared. So I realize that the second derivative here is really just going to be negative x dy dx minus y all over x squared. And we're good, right? We got this. Insert long pause, wait for students to interact with thoughts of others. ... We're done?
I mean, it looks like we found what they were asking, but it looks super messy still. Like, it doesn't look like that should be our final answer.
Why? Just say what the ugliness is. You don't need to raise hands.
dy dx.
That's hideous. But what is dy dx?
Well, we have it with it's negative 2 minus y over x.
Right. That thing, and I'm so upset that I used so many colors on top of my stuff already. Right, so I'm going to rewrite it right here. This thing right there, you know, that dy dx that we really need is just right here. So can't we just substitute that back in and it would look prettier? Wouldn't have so many different variables kind of floating around. And so in the end, then we're going to have x multiplied by negative 2, subtract y over x, subtract y all over x squared. Which still looks like I could clean it up. Now, in theory, if this is a free response question, feel free, leave it alone. You know, I definitely have a function. I don't need to simplify. But if it's multiple choice, I should be able to clean it up. So I'm going to distribute the x, which is going to be nice. I'm going to give myself some space over here. So it's going to be negative 2x, subtract, and I love what's happening with this next distribution, because if you look, that x in the denominator is going to cancel out, which is great. Then we have that. It's all over x squared.
Is it positive 2x? Because there's a negative on the first.
Oh, I forgot to have the negative out here. There you go. How's that? Is that better?
Sure.
And then you're saying we could actually go ahead and distribute that negative to the whole fraction, right? Because that really, this negative here is affecting everything. So we can really, well, simplify. We're going to have 2x, right? And then this would really be a negative 2y right there. But then that negative's kind of coming through. So we're going to have plus 2y. And it's all going to be over x squared. And this is our second derivative.
So just to clarify, Painter, a free response grader would not give us the points if we left that first derivative in the equation?
Correct.
Or in the, okay.
This would be a no-go on a free response. This would be a sure. Okay, because all that the sure requires is I can just plug in my x's and y's, so it is a formula ready to utilize. Whereas this one here actually requires way more thought on the grader or on the person using the formula. They'd have to realize they can find the first derivative first and plug it in. So they're kind of actually having to think some calculus in there, and the calculation is just more complex. And I know we're over, so if you guys need to go. Yeah, Ariana.
Where? Oh, I see it now. Sorry, my bad.
Cool.
I was wondering where the negative came from, the lead coefficient negative, but I saw it. I forgot to bring down the -1 that we multiplied everything by.
Got it. Other thoughts? Other questions?